So that being said, what really happens when there's no cooling? In a real molding process, the heat is transferred from the molten plastic into the mold by conduction. If we if we don't consider cooling, then we are essentially neglecting this effect completely. The heat from the mold is then transferred from the mold into the cooling system, which radiates out and also radiates out into its surroundings. This creates a distribution of temperature throughout the mold. If there's no cooling in the simulation, heat is assumed to transfer ideally through the part surface, and the surface temperature is set to the mold temperature. So if we set our cooling channels, let's say to, or I guess in this situation, there are no cooling channels. So if we set our mold temperature or our ideal mold temperature to, let's say 80 degrees, instead of the 80 degrees being applied to our mold, the 80 degrees is applied directly to the surface of our part, which you might actually already kind of identify as maybe a problem, and it certainly is. The temperature distribution in the mold is completely lost, and any hot spots that might occur due to either the geometry or the lack of cooling, whatever, are neglected, which means that any sort of temperature variance, so anything like what we saw in the previous slide, would be completely neglected, and you wouldn't really be able to see that sort of warpage effect. All right, so what happens if we don't have a cooling system? It's actually very common for a simulation in the early design phase to have limited simulation inputs. And the reason for that is simply because, well, we're designing the part, we don't necessarily have all of the information that we need to be able to simulate the cooling process, right? We can really only get the part, and maybe we can start experimenting with some gating locations, but even that sometimes isn't set in stone. So how do we run the simulation up front if we don't have that much information to start with? Oops, all right, there we go. The problem is that the part design indicates where the hotspots are in the mold. Neglecting those hotspots in the simulation will significantly alter the warpage numbers obtained from the simulation. So even if we, we don't necessarily have all of the inputs that we need to run the simulation. However, if we don't include some of those inputs that we don't have, then the simulation outputs as far as warpage are concerned is going to be actually completely different than if we actually include some of those elements. So including the mold base, you can see here we can have a hot spot on the top side in here and a hot spot on the bottom side in here, but everywhere else it's significantly cooler. That sort of temperature variance is not going to be able to be available if we don't have some sort of cooling system.